Question 1. The analysis reveals that a large enterprise is experiencing challenges in consistently applying security and quality of service policies across its diverse application portfolio within its Cisco ACI fabric. The current implementation has resulted in a high degree of manual configuration and a growing number of policy exceptions, leading to increased operational overhead and potential compliance risks. Which of the following approaches best addresses these challenges while adhering to ACI's design principles and promoting long-term manageability? Option A. Create highly granular and duplicated policies for each individual endpoint or server, ensuring absolute specificity for every network interaction, even if it leads to a significant increase in the total number of policies managed. Option B. Implement a layered policy approach, defining common security and co-S requirements at the tenant or application profile level, and then refining these policies with specific EPG or contract configurations where necessary, minimizing duplication and leveraging ACI's hierarchical structure. Option C. Adopt a strategy of minimal policy definition, focusing primarily on basic connectivity and allowing most traffic by default, with only critical security policies implemented at the contract level. Option D. Centralize all policy management within a single, monolithic policy group that encompasses all applications and endpoints, simplifying the initial setup, but requiring extensive manual adjustments for any future changes. The correct answer is B. Implement a layered policy approach, defining common security and co-S requirements at the tenant or application profile level, and then refining these policies with specific EPG or contract configurations, where necessary, minimizing duplication and leveraging ACI's hierarchical structure. Explanation. The analysis reveals a common challenge in large-scale ACI deployments, ensuring consistent and effective policy enforcement across a distributed environment. The professional challenge lies in balancing the need for granular control with the operational overhead of managing numerous, potentially conflicting, policies. This requires a deep understanding of ACI's policy model and its implications for network behavior, as well as the ability to anticipate and mitigate unintended consequences. Careful judgment is required to select an approach that is both technically sound and operationally sustainable. The correct approach represents best professional practice because it leverages ACI's hierarchical policy structure to promote consistency and reduce complexity. By defining common policies at higher levels of the hierarchy E, G, in the tenant or application profile, and allowing for specific overrides or extensions at lower levels E, G, in the EPG or contract, it minimizes redundancy and the potential for errors. This aligns with the principle of least privilege and promotes a more manageable and auditable policy framework. Furthermore, this approach facilitates easier troubleshooting and faster deployment of changes, as common policy elements can be modified once and propagated across multiple endpoints. An incorrect approach that relies on extensive, duplicated policies at the endpoint level fails to capitalize on ACI's strengths. This leads to a highly complex and brittle configuration, where changes must be made in numerous places, increasing the risk of misconfiguration and inconsistent enforcement. This approach is professionally unacceptable, as it violates best practices for network automation and scalability. It also introduces significant operational risk, making it difficult to maintain compliance with any relevant regulatory frameworks that mandate clear and auditable policy definitions. Another incorrect approach that prioritizes overly broad, permissive policies without adequate segmentation introduces significant security vulnerabilities. While seemingly simpler to implement initially, this approach directly contravenes the security principles inherent in ACI's design, which emphasizes micro-segmentation and granular policy control. Such a configuration would be a clear failure in adhering to security best practices and would likely violate regulatory requirements for data protection and access control, making it professionally unacceptable. The professional reasoning process for similar situations should involve a thorough assessment of the desired network behavior, the security requirements, and the operational capabilities of the team. It requires understanding the trade-offs between different policy implementation strategies within the ACI framework. Professionals should prioritize approaches that promote consistency, scalability, and auditability, while minimizing complexity and the potential for error. This involves a continuous evaluation of the policy model, against evolving business needs and security threats. Question 2. Process analysis reveals that a critical business application is experiencing intermittent performance degradation, and the IT operations team suspects that recent changes to the Cisco application Centric infrastructure, Answ fabric, specifically the introduction of advanced microsegmentation policies, may be contributing factors. The team is considering several approaches to diagnose and resolve the issue. Which approach best aligns with industry best practices for managing complex network infrastructure changes and ensuring operational stability and compliance? Option A. Immediately revert the microsegmentation policies to their previous state in the production environment to restore application performance, and then investigate the root cause offline. Option B. Proceed with further ACI configuration adjustments in the production environment, guided by real-time monitoring data, to fine-tune the microsegmentation policies until the application performance improves. Option C. Engage the application development team to immediately optimize the application code, assuming the ACI fabric is functioning as designed, and the issue lies solely within the application's resource utilization. Option D. Deploy a parallel, isolated ACI lab environment that mirrors the production fabric's configuration and traffic patterns, and then meticulously replicate the recent policy changes and application traffic within this lab to identify the source of the performance degradation. The correct answer is A. Immediately revert the microsegmentation policies to their previous state in the production environment to restore application performance, and then investigate the root cause offline. Explanation. Scenario analysis. Implementing Cisco application-centric infrastructure, Answ advanced features, particularly in a production environment, presents significant challenges. The complexity of ACI's policy-driven model, its integration with various network and application services, and the potential for widespread impact from misconfigurations necessitate a rigorous approach to best practices. The challenge lies in balancing the agility promised by ACI with the imperative of stability, security, and compliance. Without a structured evaluation of implementation approaches, organizations risk operational disruptions, security vulnerabilities, and failure to meet regulatory requirements. Correct approach analysis. The correct approach emphasizes a phased, risk-averse deployment strategy that prioritizes thorough validation and testing in isolated environments before migrating to production. This aligns with best practices for IT infrastructure deployments, particularly in regulated industries where auditability and demonstrable due diligence are paramount. By leveraging a dedicated lab or staging environment that mirrors the production setup as closely as possible, engineers can simulate real-world scenarios, test policy efficacy, and identify potential conflicts or performance bottlenecks without impacting live services. This proactive identification and remediation of issues significantly reduces the risk of production outages and security breaches. Furthermore, this approach facilitates comprehensive documentation and knowledge transfer, crucial for ongoing operational management and compliance audits. The emphasis on rollback planning ensures that any unforeseen issues can be swiftly addressed, minimizing downtime and business impact. Incorrect approaches analysis. Implementing ACI advanced features directly into a production environment without prior validation in a staging or lab environment represents a significant regulatory and ethical failure. This approach disregards the principle of least privilege and the need for controlled change management, which are fundamental to IT governance and security frameworks. It exposes the organization to an unacceptable level of risk, potentially leading to service disruptions, data breaches, and non-compliance with industry-specific regulations e.g. GDPR, HIPAA, PCI DSS, depending on the jurisdiction and industry. Such a failure to exercise due diligence can result in severe financial penalties, reputational damage, and legal liabilities. Another incorrect approach involves relying solely on vendor default configurations and assuming they meet all organizational security and operational requirements. This overlooks the critical need for customization and adherence to specific security policies and compliance mandates. Default settings are often designed for broad compatibility rather than specific security postures or performance optimizations. Failing to tailor ACI configurations to the organization's unique risk profile and regulatory obligations can lead to security vulnerabilities, performance degradation, and non-compliance. This demonstrates a lack of proactive risk management and a failure to uphold the professional responsibility to secure and optimize the infrastructure. Third incorrect approach is to bypass formal change control processes and implement changes based on informal requests or perceived urgency without proper documentation or peer review. This undermines the integrity of the change management lifecycle, which is essential for maintaining a stable and auditable infrastructure. It increases the likelihood of errors, makes troubleshooting more difficult, and hinders the ability to demonstrate compliance during audits. This approach violates principles of accountability and transparency, essential for professional IT operations and regulatory adherence. Professional reasoning. Professionals tasked with implementing advanced ACI features must adopt a risk-based decision-making framework. This involves a thorough understanding of the potential impact of changes, the organization's risk tolerance, and applicable regulatory requirements. The process should begin with a detailed assessment of requirements, followed by the design and implementation of changes in a controlled, non-production environment. Rigorous testing, validation, and a comprehensive rollback plan are essential before any production deployment. Continuous monitoring and performance analysis post-deployment are also critical for maintaining stability and security. Adherence to established change management processes, documentation standards, and security best practices ensures that implementations are not only technically sound, but also compliant and professionally responsible. Question 3. Compliance review shows a critical security vulnerability has been identified in a core application managed by Cisco ACI. The vulnerability could allow unauthorized access to sensitive data. The security team has provided a patch, but there are concerns that applying it directly to the production environment might cause application instability and service disruption. The business operations team is emphasizing the need for immediate restoration of full functionality. What is the most appropriate best practice approach to address this situation? Option A. Deploy the patch immediately to the production environment to mitigate the security risk as quickly as possible, prioritizing security over potential temporary instability. Option B. Document the vulnerability and its potential impact, but defer any remediation efforts until the next scheduled maintenance window to avoid any immediate operational impact. Option C. Implement a temporary workaround that blocks the exploit vector while a comprehensive testing and validation plan for the patch is developed and executed in a non-production environment. Option D. Escalate the issue to senior management and request a temporary shutdown of the affected application until a permanent solution can be deployed without any risk of disruption. The correct answer is A. Deploy the patch immediately to the production environment to mitigate the security risk as quickly as possible, prioritizing security over potential temporary instability. Explanation. Scenario analysis. This scenario presents a common challenge in network operations where a critical security vulnerability is identified in a widely deployed application. The challenge lies in balancing the immediate need to mitigate the risk with the potential disruption to business operations caused by implementing a fix or workaround. The pressure to restore service quickly can lead to rushed decisions that might overlook long-term implications or compliance requirements. Careful judgment is required to select an approach that is both effective in addressing the vulnerability and compliant with organizational policies and relevant industry best practices for secure network implementation. Correct approach analysis. The correct approach involves a multifaceted strategy that prioritizes a comprehensive understanding of the vulnerability and its impact before implementing a solution. This includes thorough testing of any proposed patches or workarounds in a non-production environment to ensure they do not introduce new issues or negatively affect application performance. Furthermore, it necessitates clear communication with stakeholders, including security teams, application owners, and business units, to manage expectations and coordinate the deployment. This approach aligns with Cisco's best practices for ACI, emphasizing a structured and controlled deployment process that minimizes risk and ensures operational stability. It also implicitly adheres to general cybersecurity principles of risk assessment, mitigation, and incident response, which are foundational to secure IT infrastructure management. Incorrect approach is analysis. Implementing a patch without prior testing in a production environment is a significant regulatory and ethical failure. It directly violates the principle of due diligence in IT security and operational management. Such an action could lead to service outages, data corruption, or even introduce new security vulnerabilities, all of which can have severe financial and reputational consequences for the organization. It also fails to adhere to standard IT change management processes, which are often mandated by internal policies and sometimes by external regulations to ensure stability and security. Applying a temporary workaround without a clear plan for a permanent fix is also professionally unacceptable. While it might offer immediate relief, it leaves the system exposed to the original vulnerability in the long term. This constitutes a failure to adequately address the identified risk and can be seen as negligence, especially if the workaround itself is not robust or is poorly implemented. It also bypasses the structured approach to vulnerability management, which typically requires a permanent remediation plan. Ignoring the vulnerability due to perceived low risk or lack of immediate impact is a critical failure. Cybersecurity best practices and regulatory frameworks, even if not explicitly stated for this exam, general principles apply, mandate proactive risk management. Ignoring a known vulnerability, regardless of perceived immediate impact, is a dereliction of duty and exposes the organization to potential future breaches. This approach demonstrates a lack of understanding of the evolving threat landscape and the potential for vulnerabilities to be exploited over time. Professional reasoning. Professionals should adopt a structured decision-making process that begins with a thorough risk assessment of the vulnerability. This involves understanding the exploitability, potential impact, and the affected systems. Following the risk assessment, a detailed plan for remediation should be developed, which includes evaluating available patches, workarounds, and their respective risks and benefits. This plan should then be reviewed and approved by relevant stakeholders. Implementation should always occur in a controlled manner, starting with testing in a staging environment before proceeding to production. Continuous monitoring and validation post-implementation are crucial to ensure the effectiveness of the chosen solution and the stability of the environment. This systematic approach ensures that decisions are informed, risks are managed, and compliance with organizational policies and industry best practices is maintained. Question 4. During the evaluation of a new Cisco ACI deployment aimed at accelerating application delivery, what best practice approach should be prioritized to ensure both agility and robust security posture, aligning with general principles of secure network implementation and operational governance? Option A. Rely on traditional firewall rules and manual security configurations applied to the network infrastructure outside of the ACI fabric to manage application security. Option B. Prioritize rapid application deployment by enabling broad network access initially and addressing security configurations as a post-deployment remediation task to avoid delaying service delivery. Option C. Focus on network connectivity and performance optimization, assuming that application-level security measures will be sufficient to protect the environment. Option D. Implement a comprehensive security policy model within ACI that defines granular access controls and segmentation for all deployed applications. Ensuring security is an integral part of the deployment workflow. The correct answer is D. Implement a comprehensive security policy model within ACI that defines granular access controls and segmentation for all deployed applications. Ensuring security is an integral part of the deployment workflow. Explanation. This scenario presents a professional challenge because it requires balancing the immediate need for network agility and application deployment speed with the long-term implications of security posture and compliance. The pressure to deliver services quickly can lead to shortcuts that compromise fundamental security principles, potentially exposing the organization to significant risks and regulatory scrutiny. Careful judgment is required to ensure that the implementation of ACI, while enabling rapid application deployment, does not inadvertently create vulnerabilities or violate established security policies and compliance mandates. The correct approach represents best professional practice because it prioritizes a structured, policy-driven deployment that integrates security and compliance from the outset. By leveraging ACI's capabilities for micro-segmentation and policy enforcement, the team can ensure that applications are deployed with the appropriate security controls already in place, aligning with the principle of security by design. This proactive stance minimizes the risk of introducing misconfigurations or security gaps that could be exploited later. It also ensures that the deployment adheres to relevant industry standards and internal governance frameworks, which are critical for maintaining a strong security posture and avoiding regulatory penalties. An incorrect approach that focuses solely on rapid deployment without considering the underlying security policies fails to uphold professional responsibility. This oversight can lead to regulatory failures by violating data protection regulations, e.g., GDPR, CCPA, depending on jurisdiction. Though for this exam, we focus on general principles of secure network implementation, as per Cisco's best practices for ACI, that mandate appropriate security measures for data in transit and at rest. Ethically, it demonstrates a disregard for the organization's security and the potential impact on its customers or stakeholders. Another incorrect approach, which involves manual configuration of security policies outside of ACI's framework, introduces significant operational risks. This can lead to inconsistencies, human error, and a lack of centralized visibility and control, making it difficult to audit and maintain compliance. This approach undermines the very benefits ACI offers in terms of automated policy enforcement and can result in regulatory noncompliance due to the inability to consistently demonstrate adherence to security requirements. The professional reasoning process for similar situations should involve a thorough understanding of the organization's security policies, compliance obligations, and the capabilities of the ACI platform. Before initiating any deployment, a risk assessment should be conducted, identifying potential security and compliance implications. The team should then develop a deployment strategy that leverages ACI's features to enforce these policies automatically. Continuous monitoring and auditing of the ACI fabric are essential to ensure ongoing compliance and security. Collaboration between network engineers, security teams, and compliance officers is crucial to ensure all requirements are met. Question 5. The monitoring system demonstrates an unusual spike in the number of unauthenticated API calls to the APIC controller from an internal subnet that is not typically associated with direct APIC management. While no immediate security alerts have been triggered, this deviation from the established baseline warrants further investigation. Which of the following represents the most professional and secure approach to addressing this situation? Option A. Increase the logging verbosity for all API calls to the APIC controller and monitor for any further unusual activity without actively investigating the current spike. Option B. Log the anomaly for future review during the next scheduled security audit, assuming that the absence of critical alerts indicates no immediate threat. Option C. Temporarily block all API access from the identified subnet to the APIC controller as a precautionary measure until the source of the calls can be definitively identified and authorized. Option D. Initiate a detailed forensic analysis of the source subnet and the specific applications or services generating these API calls, cross-referencing with ACI's security policies and access control lists to identify any unauthorized access attempts or misconfigurations. The correct answer is D. Initiate a detailed forensic analysis of the source subnet and the specific applications or services generating these API calls, cross-referencing with ACI's security policies and access control lists to identify any unauthorized access attempts or misconfigurations. Explanation. The monitoring system demonstrates a critical failure in identifying a potential security vulnerability within the Cisco application Centric infrastructure, ACI fabric. The challenge lies in interpreting the raw data provided by the monitoring system and correlating it with established best practices for ACI security and operational integrity. Professionals must move beyond simply observing alerts to actively analyzing their implications within the context of the ACI framework and its intended security posture. The correct approach involves a proactive and context-aware analysis of the monitoring data. This means understanding that a deviation from expected behavior, even if not immediately flagged as a critical incident, can indicate a subtle but significant security risk or operational inefficiency. Best professional practice dictates that such anomalies should be investigated thoroughly to determine their root cause and potential impact. This aligns with the principle of continuous monitoring and proactive threat mitigation, which is essential for maintaining a secure and resilient network infrastructure. In the context of ACI, this includes understanding the implications of policy misconfigurations, unauthorized access attempts, or unexpected traffic patterns that could be exploited. An incorrect approach would be to dismiss the observed behavior as benign without further investigation. This represents a failure to adhere to due diligence and a lack of proactive security posture. Ethically, it can be considered negligence if a known vulnerability or misconfiguration is left unaddressed, potentially leading to a breach. Specifically, ignoring unusual traffic patterns that deviate from established baselines could mean overlooking an active intrusion attempt or a misconfigured policy that inadvertently exposes sensitive data. Another incorrect approach is to focus solely on the immediate symptoms without understanding the underlying ACI configuration or policy that might be causing the anomaly. This superficial analysis fails to address the root cause and leaves the system vulnerable to recurring issues. The professional decision-making process should involve a systematic approach. First, understand the observed anomaly in the context of ACI's operational model and security policies. Second, correlate the anomaly with known vulnerabilities or best practice deviations. Third, prioritize investigation based on potential impact. And fourth, implement corrective actions with thorough validation. This structured approach ensures that all potential risks are evaluated and addressed effectively, maintaining the integrity and security of the ACI environment. Question 6. Governance review demonstrates that the Cisco ACI fabric's initial deployment, while functional, has several configurations that deviate from the organization's established security hardening guidelines and operational best practices. These deviations were introduced to expedite service delivery during the initial rollout. What is the most appropriate and professionally responsible approach to address these findings? Option A. Immediately revert all configurations identified as non-compliant with security hardening guidelines and operational best practices without further analysis to ensure immediate adherence to policy. Option B. Develop and execute a phased remediation plan, prioritizing critical security and operational risks, with thorough impact assessments and stakeholder engagement to bring the ACI fabric into compliance with established guidelines. Option C. Ignore the findings of the governance review and continue operating the ACI fabric as is, assuming that the current functionality is sufficient and the deviations do not pose significant risks. Option D. Implement ad hoc configuration changes to address the identified deviations as time permits, without a formal plan or stakeholder notification, to quickly resolve the issues. The correct answer is B. Develop and execute a phased remediation plan, prioritizing critical security and operational risks, with thorough impact assessments and stakeholder engagement, to bring the ACI fabric into compliance with established guidelines. Explanation. Scenario analysis. This scenario presents a common challenge in large-scale network deployments where the initial implementation of a new technology like Cisco ACI might not fully align with evolving operational best practices or the original governance framework. The challenge lies in balancing the need for immediate operational stability and functionality with the imperative to adhere to established governance and security policies. The pressure to deliver services quickly can sometimes lead to shortcuts or deviations from best practices, which, if unaddressed, can create technical debt, security vulnerabilities, and operational inefficiencies. The need for a proactive and systematic approach to remediation is critical to ensure the long-term health and compliance of the ACI fabric. Correct approach analysis. The correct approach involves a systematic, phased remediation plan that prioritizes critical security and operational risks identified during the governance review. This approach is best professional practice because it demonstrates a commitment to continuous improvement and adherence to established governance frameworks. By engaging stakeholders, conducting thorough impact assessments, and implementing changes in a controlled manner, e.g., during maintenance windows, it minimizes disruption to ongoing services. This aligns with the principles of responsible network management and security best practices, ensuring that the ACI fabric remains secure, compliant, and performant. The focus on documentation and validation reinforces accountability and provides a clear audit trail, which is essential for regulatory compliance and internal governance. Incorrect approaches analysis. One incorrect approach involves immediately reverting all non-compliant configurations without a proper impact assessment. This is a regulatory and ethical failure because it disregards the operational impact on critical business services. Hasty rollback could lead to service outages, data loss, and significant financial repercussions, violating the duty of care to maintain service availability. It also fails to acknowledge that some deviations might have been necessary or have become de facto operational standards that require careful integration rather than outright removal. Another incorrect approach is to ignore the findings of the governance review and continue operating with the identified noncompliance. This represents a severe regulatory and ethical failure. It demonstrates a disregard for established governance policies, security mandates, and potentially industry best practices. This inaction increases the risk of security breaches, audit failures, and potential legal or financial penalties. It undermines the integrity of the governance framework and exposes the organization to unacceptable risks. A third incorrect approach is to implement ad hoc fixes without a documented plan or stakeholder buy-in. This is a failure in professional practice and governance. It lacks the rigor required for managing complex infrastructure, leading to potential inconsistencies, unintended consequences, and difficulty in troubleshooting. It bypasses essential change control processes, which are often mandated by regulatory requirements and are crucial for maintaining a stable and auditable environment. Professional reasoning. Professionals facing such a situation should adopt a structured decision-making process. First, thoroughly understand the findings of the governance review and the specific deviations from best practices or policies. Second, prioritize the identified issues based on their potential impact on security, operational stability, and compliance. Third, engage relevant stakeholders, e.g., security teams, application owners, to discuss the findings and potential remediation strategies. Fourth, develop a detailed, phased remediation plan that includes impact assessments, rollback procedures, and testing protocols. Fifth, execute the plan in a controlled manner, adhering to change management processes. Finally, document all changes and validate the successful remediation of the identified issues, ensuring ongoing monitoring and adherence to governance. This systematic approach ensures that remediation efforts are effective, minimize risk, and uphold professional and regulatory standards. Question 7. Regulatory review indicates that the organization's implementation of Cisco application-centric infrastructure, Answ, must demonstrably adhere to strict data segregation and access control mandates. Which of the following approaches best aligns with these regulatory requirements and ACI best practices for ensuring compliance? Option A. Deploying ACI with broad administrative access for all network engineers and disabling detailed logging to simplify operational management. Option B. Implementing granular contracts between application and point groups to enforce communication policies and leveraging ACI's role-based access control to restrict administrative privileges to specific domains and tenants. Option C. Implementing ACI without specific policy enforcement for inter-EPG communication, assuming that application developers will manage internal data flow security. Option D. Relying solely on traditional firewall appliances at the network perimeter to protect the ACI fabric and assuming ACI's default security settings are sufficient for regulatory compliance. Correct answer is B. Implementing granular contracts between application and point groups to enforce communication policies and leveraging ACI's role-based access control to restrict administrative privileges to specific domains and tenants. Explanation. Scenario analysis. Implementing ACI in a regulated environment, particularly one with stringent data privacy and security mandates, presents a significant challenge. The core difficulty lies in balancing the agility and automation offered by ACI with the need for auditable, compliant, and secure network operations. Organizations must ensure that their ACI deployment adheres to specific regulatory frameworks, such as those governing financial services or healthcare, which often dictate how data is handled, accessed, and protected. Failure to do so can result in severe penalties, reputational damage, and loss of customer trust. The dynamic nature of ACI, with its policy-driven approach, requires a proactive and integrated compliance strategy rather than a reactive one. Correct approach analysis. The correct approach involves integrating compliance and security best practices directly into the ACI design and operational lifecycle. This means leveraging ACI's capabilities for policy enforcement, micro-segmentation, and role-based access control to meet regulatory requirements. For instance, using ACI's contract-based communication policies to enforce data flow restrictions between application tiers aligns with regulations that mandate data segregation and access control. Implementing granular RBAC within ACI ensures that only authorized personnel can manage specific network segments or policies, directly addressing compliance mandates around access management and the principle of least privilege. Continuous monitoring and auditing of ACI configurations and traffic flows, facilitated by ACI's built-in telemetry and integration with SIEM tools, are crucial for demonstrating compliance to auditors and regulatory bodies. This proactive, policy-driven integration ensures that security and compliance are inherent to the ACI fabric, not an afterthought. Incorrect approach is analysis. One incorrect approach is to treat ACI as a purely technical implementation, assuming that existing, traditional network security controls are sufficient. This fails to acknowledge that ACI's policy model fundamentally changes network management and security. Regulatory frameworks often require specific controls and audit trails that may not be adequately addressed by legacy security appliances or manual configurations. Relying solely on perimeter security without leveraging ACI's micro-segmentation capabilities, for example, would be a significant regulatory failure, as many modern regulations emphasize internal data protection and lateral movement prevention. Another incorrect approach is to implement ACI with overly broad access policies or insufficient RBAC. This directly violates the principle of least privilege, a common requirement in many regulatory frameworks. If administrators have excessive permissions, it increases the risk of accidental misconfigurations or malicious activity, making it difficult to demonstrate accountability and control, which are critical for compliance audits. A third incorrect approach is to neglect the importance of continuous monitoring and auditing of the ACI fabric. Many regulations require organizations to maintain detailed logs of network activity, configuration changes, and access events. Without a robust monitoring strategy integrated with ACI, organizations cannot effectively detect policy violations, investigate security incidents, or provide the necessary evidence for compliance reporting. This lack of visibility and auditability is a direct contravention of regulatory expectations. Professional reasoning. Professionals must adopt a risk-based and compliance-aware approach when implementing ACI. This involves understanding the specific regulatory landscape applicable to their organization and mapping those requirements to ACI's features and capabilities. The decision-making process should prioritize security and compliance by design, ensuring that policies are defined with regulatory mandates in mind from the outset. This includes thorough planning, rigorous testing, and the establishment of clear operational procedures for managing and monitoring the ACI fabric. Regular reviews of ACI configurations against evolving regulatory requirements are essential to maintain an ongoing state of compliance. Question 8. The risk matrix shows a high likelihood of security misconfigurations and potential compliance violations during the initial rollout of Cisco ACI's advanced policy enforcement features, particularly concerning the implementation of micro-segmentation for sensitive data zones. What is the most appropriate strategy to mitigate these risks while ensuring successful ACI adoption? Option A. Implement ACI with a focus on core network functionality first, deferring granular micro-segmentation policies and comprehensive compliance validation to a later phase after the initial operational stability is achieved. Option B. Prioritize rapid deployment of ACI across the entire infrastructure to gain immediate operational benefits, assuming that the inherent security features of ACI will automatically address any potential compliance issues. Option C. Conduct a thorough pre-implementation risk assessment and compliance gap analysis. Develop detailed ACI policies that directly map to regulatory requirements, and implement micro-segmentation in a phased approach with continuous validation and auditing. Option D. Rely solely on existing perimeter security controls and assume that ACI's internal network segmentation capabilities will not introduce new compliance challenges, thus requiring minimal changes to current security policies. The correct answer is A. Implement ACI with a focus on core network functionality first, deferring granular micro-segmentation policies and comprehensive compliance validation to a later phase after the initial operational stability is achieved. Explanation. This scenario presents a professional challenge rooted in the inherent complexity of implementing advanced network solutions like Cisco ACI within a regulated environment. The core difficulty lies in balancing the rapid pace of technological deployment with the stringent requirements for security, compliance, and operational stability mandated by industry regulations. Specifically, the challenge is to ensure that the implementation of ACI's advanced features, such as micro-segmentation and policy-driven automation, does not inadvertently create security vulnerabilities or compliance gaps that could lead to significant financial penalties or reputational damage. Careful judgment is required to select an implementation strategy that is both effective from a technical standpoint and fully compliant with the relevant regulatory framework. The correct approach represents best professional practice because it prioritizes a phased, risk-aware deployment that integrates security and compliance checks at every stage. This aligns with the principles of secure by design and compliance by design, which are fundamental to responsible technology implementation in regulated sectors. By conducting thorough pre-implementation assessments, leveraging ACI's policy enforcement capabilities for granular security, and establishing robust monitoring and auditing mechanisms, the organization demonstrates a commitment to maintaining a secure and compliant infrastructure. This proactive stance minimizes the likelihood of breaches and regulatory violations, thereby safeguarding the organization's interests. An incorrect approach that bypasses or inadequately addresses security and compliance during the initial deployment phase represents a significant regulatory and ethical failure. For instance, prioritizing speed of deployment over comprehensive security validation could lead to the introduction of exploitable vulnerabilities, directly contravening regulations that mandate the protection of sensitive data and systems. Similarly, neglecting to map ACI policies to specific compliance requirements, e.g., data segregation for PCI DSS or access controls for HIPAA, would be an ethical lapse, as it fails to uphold the organization's responsibility to protect its customers and adhere to legal obligations. Another failure would be to implement ACI without adequate training for operational staff, leading to misconfigurations that could compromise security or compliance, thus demonstrating a lack of due diligence. The professional reasoning process for similar situations should involve a structured risk assessment, followed by a phased implementation plan that incorporates continuous security and compliance validation. This includes engaging stakeholders from security, compliance, and operations early in the project lifecycle. A critical step is to thoroughly understand the specific regulatory requirements applicable to the organization and to map these directly to ACI's capabilities. Post-implementation, ongoing monitoring, regular audits, and a well-defined incident response plan are essential to ensure sustained security and compliance. Question 9. Strategic planning requires a proactive approach to integrating new network functionalities, especially when a critical business application's performance is dependent on the stability and security of the underlying infrastructure. Given the recent introduction of a new ACI feature that promises enhanced application visibility, but has raised potential security concerns during initial internal discussions, what is the most responsible course of action to ensure both rapid deployment and adherence to security best practices? Option A. Conduct a comprehensive security assessment and pilot testing of the new ACI feature in a non-production environment, followed by a phased rollout into production, ensuring all security concerns are addressed before full deployment. Option B. Proceed with the implementation of the new ACI feature in the production environment immediately, deferring any in-depth security validation until after the application has been successfully deployed and is operational. Option C. Implement the new ACI feature directly into the production environment to meet the urgent business demand, relying on post-deployment monitoring to identify and address any security issues that arise. Option D. Deploy the new ACI feature to the production environment without further security review, prioritizing the business application's immediate availability over potential, unconfirmed security risks. The correct answer is C. Implement the new ACI feature directly into the production environment to meet the urgent business demand, relying on post-deployment monitoring to identify and address any security issues that arise. Explanation. Scenario analysis. This scenario presents a professional challenge rooted in the inherent tension between rapid deployment of new technologies and the imperative to maintain robust security and compliance within a regulated environment. The pressure to deliver a functional ACI fabric quickly for a critical business application, coupled with the potential for a security vulnerability in a newly implemented feature, demands careful judgment. The challenge lies in balancing agility with due diligence, ensuring that the pursuit of innovation does not inadvertently create unacceptable risks or violate established security policies and regulatory mandates. The organization's reliance on the application amplifies the stakes, making any misstep potentially impactful. Correct approach analysis. The correct approach prioritizes a phased rollout and rigorous validation, aligning with best practices for secure and compliant network deployments. This strategy involves a controlled introduction of the new ACI feature, starting with a non-production or isolated segment of the network. This allows for thorough testing of its security implications, performance characteristics, and interoperability without impacting live services. The process would include detailed security reviews, vulnerability assessments, and adherence to the organization's established change management and security policy frameworks. This methodical approach ensures that potential issues are identified and remediated before widespread deployment, thereby upholding the organization's commitment to security and compliance and preventing potential regulatory breaches related to data protection and service availability. Correct approaches analysis. Implementing the new ACI feature directly into the production environment without prior testing or validation represents a significant regulatory and ethical failure. This bypasses essential security controls and risk assessment processes, potentially exposing sensitive data or critical services to vulnerabilities. Such an action could lead to non-compliance with data privacy regulations e.g. GDPR if applicable to the jurisdiction, or equivalent local regulations concerning data handling and security, and industry-specific compliance standards, resulting in substantial fines and reputational damage. Deploying the feature with a wait-and-see attitude, relying solely on post-deployment monitoring to detect issues, is also professionally unacceptable. This approach abdicates responsibility for proactive risk management. It fails to meet the ethical obligation to implement systems with a reasonable degree of certainty regarding their security and stability. Furthermore, it neglects the regulatory requirement to implement appropriate technical and organizational measures to ensure the security of processing, as mandated by data protection laws. Ignoring the security team's concerns and proceeding with the deployment based solely on business urgency demonstrates a disregard for established security governance and risk management protocols. This creates an environment where security is treated as an afterthought, increasing the likelihood of breaches and non-compliance. Ethically, it undermines the principles of responsible technology adoption and can lead to a culture where security is compromised for expediency, potentially violating the organization's duty of care to its customers and stakeholders. Professional reasoning. Professionals in this domain must adopt a risk-based decision-making framework. This involves 1. Understanding the business requirements and urgency, but never at the expense of security and compliance. 2. Conducting a thorough risk assessment of any new technology or feature, identifying potential security vulnerabilities and compliance gaps. 3. Developing a phased implementation plan that includes robust testing, validation, and rollback procedures. 4. Engaging all relevant stakeholders, including security, compliance, and operations teams, throughout the planning and deployment process. 5. Adhering strictly to the organization's change management policies and regulatory obligations. When faced with conflicting priorities, the professional's duty is to advocate for the approach that best mitigates risk and ensures compliance, even if it requires more time or resources. Question 10. Implementation of a secure network segmentation strategy within Cisco ACI to isolate sensitive customer data traffic from general application traffic requires careful consideration of policy enforcement mechanisms. Given the need for granular control and auditability, which of the following approaches best aligns with ACI's design principles and ensures robust isolation? Option A. Defining distinct endpoint groups, EP, for sensitive data and general application traffic, and enforcing communication policies between these EPGs using contracts that explicitly permit only necessary interactions. Option B. Implementing separate virtual routing and forwarding, VRF, instances for sensitive data and general application traffic, relying solely on VRF isolation without further granular policy enforcement. Option C. Configuring external firewalls with complex access control lists, ACL, to manage traffic flow between the segments, bypassing ACI's native policy constructs for this specific isolation. Option D. Creating broad EPGs that encompass both sensitive data and general application traffic, and relying on the default deny behavior of ACI to prevent unauthorized access. Correct answer is A. Defining distinct endpoint groups, EP, for sensitive data and general application traffic, and enforcing communication policies between these EPGs using contracts that explicitly permit only necessary interactions. Explanation. This scenario presents a professional challenge due to the critical nature of network segmentation for security and compliance within an application-centric infrastructure. ASI environment. The requirement to isolate sensitive data traffic from general application traffic necessitates a robust and well-defined policy enforcement mechanism. The challenge lies in selecting the most effective and compliant method for achieving this isolation, ensuring that the chosen approach aligns with ACI's design principles and any relevant industry best practices or regulatory mandates that might implicitly govern data handling and network security, even if not explicitly stated as laws in a direct sense for this exam scope. The correct approach leverages ACI's native capabilities for policy-driven segmentation, specifically through the use of EPGs and contracts. This method is best professional practice because it directly maps to the ACI model of intent-based networking. By defining EPGs that represent distinct security zones, and then establishing contracts that explicitly permit or deny communication between them, administrators enforce granular security policies at the fabric level. This ensures that traffic is only allowed where explicitly permitted, providing a strong security posture and facilitating auditability. This aligns with the principle of least privilege and is a fundamental tenet of secure network design, implicitly supporting compliance objectives related to data protection and access control. An incorrect approach that relies solely on VRF isolation without granular EPG/contract policies fails to provide sufficient segmentation for sensitive data. While VRFs isolate routing tables, they do not inherently control inter-VRF communication at the application or tenant level. This can lead to unintended data exposure if not further secured, potentially violating implicit data handling guidelines. Another incorrect approach that involves manual firewall rule management outside of ACI's policy model introduces significant operational overhead and increases the risk of misconfiguration. This bypasses the centralized, automated policy enforcement of ACI, making it difficult to maintain consistency and auditability, which are crucial for any compliance framework. A third incorrect approach that uses broad EPG definitions without specific contracts for sensitive data allows for excessive communication pathways, undermining the principle of least privilege and potentially exposing sensitive data to unauthorized access. This lack of explicit control is a direct failure in implementing robust security segmentation. Professionals should approach such decisions by first understanding the specific security and compliance requirements for the data in question. Then, they should evaluate how ACI's native constructs, such as EPGs, contracts, and VRFs, can be used to meet these requirements. The decision-making process should prioritize solutions that are policy-driven, automated, and auditable, aligning with the core principles of ACI and best practices for secure network segmentation. Question 11. Risk assessment procedures indicate that a new ACI fabric deployment for a financial services organization must adhere to strict data segregation and access control mandates. The implementation team is under pressure to bring critical applications online rapidly, which approach best balances rapid deployment with robust security and compliance. Option A. Prioritize application connectivity and functionality above all else during the initial deployment, deferring detailed security policy configuration and compliance checks until after the network is fully operational. Option B. Enable all traffic by default across the fabric and plan to implement granular security policies and contracts after the initial application deployment is complete. Option C. Define all endpoint groups EPC and their inter-EPG communication policies, contracts, in a controlled, phased manner, starting with essential services and progressively enabling broader communication as security validation is completed. Option D. Deploy the ACI fabric with a broad, flat network policy that allows extensive inter-EPG communication, with the intention of refining security rules and contracts over time as operational experience is gained. The correct answer is C. Define all endpoint groups EPG and their inter-EPG communication policies, contracts in a controlled, phased manner, starting with essential services and progressively enabling broader communication as security validation is completed. Explanation. Scenario analysis. This scenario presents a professional challenge rooted in the inherent complexity of implementing advanced network fabric solutions like Cisco ACI. The challenge lies in balancing the need for rapid deployment and feature adoption, with the critical requirement for robust security and compliance. Misinterpreting or inadequately addressing the implications of ACI's policy-driven model, particularly concerning microsegmentation and contract enforcement, can lead to significant security vulnerabilities and regulatory noncompliance. The pressure to deliver a functional network quickly can tempt engineers to overlook granular security configurations, creating a false sense of security. Correct approach analysis. The correct approach emphasizes a phased implementation strategy that prioritizes the establishment of a secure baseline before enabling advanced features. This aligns with best practices in network security and compliance, which advocate for a least privilege principle. By first defining the EPGs and their inter-EPG communication policies, contracts, in a controlled manner, the implementation ensures that only explicitly permitted traffic flows are allowed. This granular control is fundamental to microsegmentation, a key ACI security tenet, and directly supports compliance requirements that mandate data isolation and access control. This methodical approach minimizes the attack surface and provides auditable proof of security posture, crucial for regulatory adherence. Incorrect approaches analysis. Implementing ACI without a clear understanding of the policy model and its security implications is a significant regulatory and ethical failure. Enabling all traffic by default and relying on later configuration is a direct violation of the principle of least privilege and creates an unacceptable security risk. This approach fails to meet compliance mandates that require documented and enforced access controls. Furthermore, it demonstrates a lack of due diligence in understanding the technology's security capabilities, which is professionally irresponsible. Deploying ACI with a broad, flat network policy and intending to refine it later without a defined plan or timeline is equally problematic. This approach creates a wide security gap, making the network vulnerable to lateral movement by attackers. It also makes auditing and demonstrating compliance extremely difficult, as the intended security state is not clearly defined or enforced. This lack of proactive security design is a failure to uphold professional standards. Focusing solely on application connectivity without considering the underlying security and compliance requirements is a common pitfall. While ACI excels at application-centric networking, neglecting the security fabric that underpins it leads to a compromised environment. This oversight can result in breaches that have severe financial and reputational consequences and directly contravenes regulatory obligations to protect sensitive data. Professional reasoning. Professionals facing ACI implementation challenges should adopt a risk-based, phased approach. This involves thorough planning, understanding the security implications of each ACI construct, EPG, contracts, filters, and prioritizing security and compliance from the outset. A structured methodology, such as starting with a secure baseline and iteratively enabling functionality, is essential. Continuous monitoring, auditing, and validation against compliance requirements are also critical components of professional network implementation. Question 12. The efficiency study reveals that a critical business application is experiencing significant performance degradation due to inter-tier communication bottlenecks within the Cisco ACI fabric. The application comprises distinct tiers, e.g., web, application, database, and the current network configuration lacks granular segmentation and appropriate quality of service, (QoS), prioritization for this application's traffic. The business requires an immediate resolution to restore application performance and prevent further impact on user productivity and revenue. What is the most effective and professionally sound approach to address this implementation challenge within the Cisco ACI framework? Option A. Implement a single, broad contract that permits unrestricted communication between all EPGs associated with the application to ensure maximum data flow. Option B. Manually configure firewall rules on external devices to manage traffic flow between the application tiers, bypassing the ACI policy model. Option C. Consolidate all application tiers into a single, large EPG to simplify network management and reduce the number of configured policies. Option D. Create a dedicated EPG for each application tier. Define specific contracts allowing only necessary communication between these EPGs, and apply appropriate co-S policies to prioritize the application's traffic. The correct answer is D. Create a dedicated EPG for each application tier. Define specific contracts allowing only necessary communication between these EPGs, and apply appropriate co-S policies to prioritize the application's traffic. Explanation. Scenario analysis. This scenario presents a professional challenge in network design and implementation, where a critical business application's performance is degraded due to suboptimal network segmentation and traffic management within an application-centric infrastructure, a SI fabric. Challenge lies in balancing the need for rapid resolution with adherence to established ACI best practices and potential regulatory compliance requirements related to data isolation and security, even if not explicitly stated as a direct compliance violation in this context. The urgency of the business impact necessitates a swift solution, but a hasty, non-compliant implementation could introduce new vulnerabilities or operational complexities. Correct approach analysis. Implementing a dedicated EPG with specific co-S policies and a contract that allows only necessary traffic between the application tiers is the best professional practice. This approach aligns with ACI's core principles of policy-driven automation and granular control. It ensures that the application's traffic is isolated and prioritized appropriately, directly addressing the performance bottleneck. From a regulatory and ethical standpoint, this method promotes data security and integrity by enforcing strict communication policies, minimizing the attack surface, and ensuring that sensitive application data is not unnecessarily exposed. This adheres to the spirit of data protection and operational integrity expected in professional IT environments. Incorrect approaches analysis. Deploying a broad, unrestricted contract between all application tiers without specific co-S or EPG segregation introduces significant security risks. It violates the principle of least privilege, potentially exposing sensitive data to unauthorized access or modification, which could have regulatory implications if data breach notification laws were triggered. This approach also fails to address the root cause of the performance issue by not prioritizing critical application traffic. Implementing a single, large EPG for the entire application suite, while seemingly simplifying management, sacrifices the granular control and segmentation that ACI provides. This lack of segmentation increases the blast radius of any security incident and makes it difficult to apply specific security or co-S policies to individual application tiers, potentially leading to compliance issues related to data segregation and auditability. Manually configuring firewall rules outside of the ACI fabric to manage traffic between application tiers bypasses the integrated policy model of ACI. This creates an operational burden, increases the likelihood of misconfiguration, and undermines the automation benefits of ACI. It also introduces a management silo, making it harder to audit and enforce consistent policies across the infrastructure, which could be a concern for regulatory compliance frameworks that require centralized policy management and auditing. Professional reasoning. Professionals should first thoroughly analyze the application's traffic flow and dependencies. Then, they should leverage ACI's policy model to create granular EPGs for each tier. Define specific contracts that permit only essential communication, and apply appropriate co-S policies to prioritize critical application traffic. This systematic, policy-driven approach ensures both performance optimization and adherence to security best practices, which are foundational to professional IT operations and implicitly support regulatory objectives. Question 13. System analysis indicates that a financial services organization is migrating its core trading platform to a microservices architecture deployed on a cloud infrastructure managed by Cisco ACI. The organization operates under strict regulatory oversight, requiring comprehensive audit trails, granular access controls, and robust data protection. The development team is pushing for rapid deployment cycles to gain a competitive advantage. What is the most appropriate approach to ensure both agility and compliance during this implementation? Option A. Focus solely on application-level security measures and defer network-level security configurations within ACI until operational issues arise. Option B. Deploy microservices with minimal network segmentation and rely on host-based security controls, assuming ACI's capabilities are primarily for network performance. Option C. Implement a policy-driven security and compliance framework within Cisco ACI, integrating security checks into the CI/CD pipeline and establishing comprehensive logging for auditability. Option D. Prioritize rapid deployment of all microservices first, then address security and compliance requirements in a subsequent phase to avoid delaying feature releases. The correct answer is C. Implement a policy-driven security and compliance framework within Cisco ACI, integrating security checks into the CI/CD pipeline and establishing comprehensive logging for auditability. Explanation. Scenario analysis. This scenario presents a professional challenge rooted in the dynamic nature of cloud-native application deployments and the inherent complexities of managing distributed systems within a regulated environment. The core challenge lies in ensuring that the implementation of a new microservices architecture, leveraging Cisco ACI for network automation, adheres to stringent security and compliance mandates without hindering agility. The pressure to deliver new features rapidly, coupled with the need for robust security controls and auditability, creates a tension that requires careful technical and procedural judgment. Missteps in this area can lead to significant security vulnerabilities, compliance violations, and operational disruptions, impacting the organization's reputation and financial standing. Correct approach analysis. The correct approach involves a phased, risk-based implementation strategy that prioritizes security and compliance from the outset. This means integrating security and compliance checks into the CI/CD pipeline, utilizing ACI's policy-driven model to enforce granular access controls and segmentation, and establishing comprehensive monitoring and logging for auditability. This approach represents best professional practice because it proactively addresses potential risks, aligns with the principles of DevSecOps, and ensures that the deployed infrastructure meets regulatory requirements. By embedding security and compliance into the design and deployment process, rather than treating them as an afterthought, organizations can achieve both agility and robust governance. This aligns with the general principles of responsible technology deployment and data protection, which are implicitly expected in any regulated industry. Incorrect approaches analysis. Implementing a move fast and break things mentality without adequate security and compliance validation would be a significant regulatory and ethical failure. This approach ignores the fundamental responsibility to protect sensitive data and maintain system integrity, potentially leading to breaches and noncompliance with data privacy laws. Deploying the microservices architecture without leveraging ACI's policy enforcement capabilities for network segmentation and access control would create a flat, insecure network, increasing the attack surface and making it difficult to isolate compromised components. This is a failure of due diligence in network security design. Relying solely on external security tools without integrating them into the ACI fabric and the CI/CD pipeline would result in a fragmented security posture, creating blind spots and hindering effective incident response. This represents a failure to adopt a holistic and integrated security strategy. Professional reasoning. Professionals facing such a scenario should adopt a structured decision-making process. First, thoroughly understand the specific regulatory and compliance requirements applicable to the organization and the data being handled. Second, assess the risks associated with the proposed microservices architecture and the ACI implementation, considering potential security vulnerabilities and compliance gaps. Third, design an implementation strategy that integrates security and compliance controls throughout the lifecycle, from design to deployment and operation. This involves leveraging the capabilities of the ACI platform for policy enforcement and automation. Fourth, establish robust monitoring, logging, and auditing mechanisms to ensure continuous compliance and facilitate incident investigation. Finally, foster collaboration between development, operations, and security teams to ensure a shared understanding of responsibilities and a unified approach to security and compliance. Question 14. Investigation of a critical network outage reveals a potential misconfiguration within the Cisco ACI fabric. The network engineer suspects a recent, unauthorized configuration change might be the root cause. The engineer needs to quickly identify the source of the problem to restore service. What is the most appropriate and ethically sound course of action to investigate the configuration history and identify the responsible party or change? Option A. Request the credentials of other network administrators to access their individual switch configurations for comparison. Option B. Share the suspected problematic configuration snippet with an external IT forum for community analysis and troubleshooting. Option C. Directly log into the APIC controllers via SSH and manually review system logs and configuration files for anomalies. Option D. Utilize the ACI GUI or API to access the configuration history and audit logs, focusing on recent changes and user activity. The correct answer is D. Utilize the ACI GUI or API to access the configuration history and audit logs, focusing on recent changes and user activity. Explanation. Scenario analysis. This scenario presents a professional challenge rooted in the ethical obligation to maintain data integrity and confidentiality within a Cisco ACI environment. The challenge lies in balancing the immediate need for troubleshooting and potential data recovery with the strict requirements for secure and authorized access to sensitive network configuration data. The temptation to bypass established security protocols for expediency, especially under pressure, is a common pitfall. Careful judgment is required to ensure that all actions taken are both effective in resolving the issue and compliant with security policies and potentially regulatory frameworks governing data handling. Correct approach analysis. The correct approach involves adhering to established incident response procedures, which mandate the use of authorized tools and documented processes for accessing and analyzing network data. This includes leveraging ACI's built-in audit logs and configuration history features. These features provide a secure, auditable trail of all configuration changes and access attempts, ensuring that any investigation is transparent and traceable. This aligns with best professional practices for network management, emphasizing accountability and the principle of least privilege. By using these authorized mechanisms, the network engineer upholds data integrity, maintains confidentiality, and ensures compliance with any applicable security policies or regulatory guidelines that require auditable access controls and data protection. Incorrect approach is analysis. One incorrect approach involves directly accessing the underlying operating system of the APIC controllers or leaf/spine switches without explicit authorization or a documented incident response ticket. This bypasses the ACI abstraction layer and its inherent security controls. This action represents a significant regulatory and ethical failure because it violates established security policies, potentially compromises the integrity of the ACI fabric's control plane, and creates an unauthorized access vector. It also undermines the auditability of actions, making it impossible to definitively track who made what changes and when, which is critical for compliance and forensic analysis. Another incorrect approach is to share sensitive configuration data, such as credentials or detailed network topology, with unauthorized personnel or through insecure communication channels. This is a direct breach of confidentiality and data protection principles. Ethically, it demonstrates a lack of responsibility in safeguarding sensitive information. From a regulatory standpoint, depending on the nature of the data and the industry, this could lead to severe penalties for data exfiltration or non-compliance with data privacy laws. It also exposes the organization to significant security risks, including potential exploitation of the disclosed information. A third incorrect approach is to attempt to manually reconfigure critical network policies or security settings on the fly without proper validation or adherence to change management procedures. While seemingly a quick fix, this introduces a high risk of unintended consequences, network instability, or security vulnerabilities. It bypasses the controlled deployment mechanisms of ACI, which are designed to prevent such errors. This failure is both an ethical lapse in professional diligence and a potential regulatory violation if it leads to a security incident or service disruption that impacts compliance obligations. Professional reasoning. Professionals facing such a dilemma should first and foremost consult their organization's incident response plan and security policies. The decision-making process should prioritize adherence to documented procedures and authorized access methods. If unsure, seeking guidance from senior network engineers, security teams, or management is crucial. The principle of do no harm applies, meaning any action taken should not exacerbate the problem or introduce new security risks. Maintaining a clear, auditable record of all actions and communications is paramount. This systematic approach ensures that troubleshooting is conducted effectively, securely, and in compliance with all relevant professional and regulatory standards. Question 15. What factors determine the most appropriate and ethical course of action when a network professional discovers a potential zero-day vulnerability during a Cisco ACI implementation that could impact client security? Option A. Documenting the vulnerability internally and waiting for Cisco to release a patch without any proactive communication. Option B. Immediately publishing the vulnerability details on public security forums to alert the broader community. Option C. Informing the client of the vulnerability and advising them to implement immediate, uncoordinated network changes. Option D. Engaging Cisco's official vulnerability disclosure program to report the finding and collaborating on a coordinated disclosure plan. The correct answer is D. Engaging Cisco's official vulnerability disclosure program to report the finding and collaborating on a coordinated disclosure plan. Explanation. This scenario presents an ethical dilemma common in advanced network implementations, specifically concerning the responsible disclosure of vulnerabilities discovered during a Cisco ACI deployment. The challenge lies in balancing the immediate need to secure the network against potential exploitation with the contractual and ethical obligations to the vendor and the client. Premature or unauthorized disclosure could jeopardize ongoing security efforts, damage vendor relationships, and potentially create a window for malicious actors if the vulnerability is not yet patched or mitigated. Conversely, withholding information indefinitely could expose the client to unacceptable risk. The core of the dilemma is navigating the gray area between proactive security and responsible communication. The correct approach prioritizes a structured, ethical, and legally sound process for vulnerability disclosure. This involves first confirming the vulnerability impact and scope within the client's specific ACI environment. Subsequently, the professional should engage with Cisco through their established channels for reporting security issues. This typically involves a vulnerability disclosure program, VDP, or a direct contact with their security team. This method ensures that Cisco is informed and can develop a patch or mitigation strategy, and it allows the client to implement temporary workarounds or enhanced monitoring under guidance. This aligns with professional ethical codes that emphasize integrity, competence, and the duty to protect client interests while respecting intellectual property and vendor relationships. It also adheres to general cybersecurity best practices that advocate for coordinated vulnerability disclosure. An incorrect approach would be to immediately disclose the vulnerability publicly without engaging Cisco. This constitutes a failure to follow coordinated vulnerability disclosure principles, potentially creating a zero-day exploit scenario that benefits attackers. It violates the implicit trust placed in the professional by both the client and the vendor. Another incorrect approach is to ignore the vulnerability, hoping it will not be discovered or exploited. This is a clear dereliction of professional duty and a failure to uphold the client's security. It exposes the client to significant risk and breaches the professional's obligation to provide competent and diligent service. A third incorrect approach might be to disclose the vulnerability only to the client without informing Cisco, especially if the client is not equipped to handle the technical implications, or if the disclosure could be misinterpreted or misused. This bypasses the established process for addressing security flaws and could lead to an uncoordinated and potentially ineffective response. Professionals facing such dilemmas should employ a decision-making framework that includes 1. Thorough assessment of the vulnerability severity and impact. 2. Review of contractual obligations and vendor disclosure policies. 3. Prioritization of client security and risk mitigation. 4. Engagement with the vendor through official channels for coordinated disclosure. 5. Documentation of all actions and communications. This systematic approach ensures that decisions are informed, ethical, and legally compliant, protecting all parties involved and upholding professional standards. Question 16. When evaluating a critical network performance issue in a Cisco ACI environment that involves analyzing traffic flows containing sensitive customer data, what is the most appropriate course of action to ensure both operational resolution and regulatory compliance? Option A. Access the raw traffic data directly, analyze it to identify the root cause, and then delete the sensitive data from local storage immediately after resolution. Option B. Bypass standard data access procedures and directly query the ACI fabric's internal logs and traffic mirrors to identify the issue, assuming the urgency justifies the deviation. Option C. Share the raw traffic data with the entire network operations team to expedite the troubleshooting process and gather multiple perspectives. Option D. Request anonymized or aggregated traffic flow data from the customer or relevant team for analysis. And if direct access is absolutely necessary, obtain explicit authorization and follow strict data handling protocols. The correct answer is A. Access the raw traffic data directly, analyze it to identify the root cause, and then delete the sensitive data from local storage immediately after resolution. Explanation: scenario analysis. This scenario presents an ethical dilemma concerning data privacy and security within a Cisco ACI environment. The challenge lies in balancing the immediate need for troubleshooting and performance analysis with the strict regulatory requirements for data handling and access. The engineer must navigate potential conflicts between operational demands and compliance obligations, where unauthorized access or mishandling of sensitive data could lead to significant legal and reputational damage. The pressure to resolve an issue quickly can tempt shortcuts that bypass established security protocols, making careful judgment paramount. Correct approach analysis. The correct approach involves adhering strictly to the established data access and handling policies, which are informed by regulatory frameworks like GDPR, General Data Protection Regulation, or similar data privacy laws relevant to the jurisdiction of operation. This means ensuring that any access to sensitive data for troubleshooting is logged, authorized, and performed by individuals with a legitimate need to know. The use of anonymized or aggregated data for analysis, where possible, is a best practice. If direct access to sensitive data is unavoidable, it must be done in a controlled environment, with strict access controls and with explicit consent or legal basis, and the data must be secured throughout the process. This approach upholds the principles of data minimization, purpose limitation, and integrity and confidentiality, which are cornerstones of data protection regulations. Incorrect approaches analysis. Accessing sensitive customer data without proper authorization or logging, even for troubleshooting, is a direct violation of data privacy regulations. It bypasses accountability mechanisms and increases the risk of data breaches or misuse. It fails to uphold the principle of accountability and can lead to severe penalties. Sharing sensitive customer data with colleagues who do not have a legitimate need to know, or without appropriate anonymization or consent, constitutes a breach of confidentiality and privacy. This exposes the organization to significant legal repercussions and erodes customer trust. It violates the principles of data minimization and purpose limitation. Ignoring or circumventing established security protocols and access control mechanisms, even with good intentions, creates vulnerabilities. This can lead to unauthorized access, data corruption, or breaches, directly contravening the principle of integrity and confidentiality and potentially violating security-specific regulations. Professional reasoning. Professionals should adopt a risk-based approach. For taking any action that involves sensitive data, they must assess the potential risks to data privacy and security against the operational necessity. This involves consulting organizational policies, relevant regulations, and seeking guidance from legal or compliance departments if unsure. Documenting all actions, especially those involving sensitive data, is crucial for accountability. Prioritizing compliance and ethical conduct over expediency ensures long-term trust and avoids detrimental consequences. Question 17. Cost-benefit analysis shows that implementing a network segmentation strategy using basic VLAN and ACLs for sensitive data isolation will be significantly cheaper and faster than deploying a more robust micro-segmentation solution with granular policy enforcement. But the latter offers superior security posture and auditability required by current industry best practices and potential future regulatory scrutiny. What is the most ethically and professionally sound course of action? Option A. Implement the cheaper VLAN and ACL-based segmentation and rely on external security audits to identify and remediate any potential vulnerabilities after deployment. Option B. Advocate for the more robust microsegmentation solution, clearly articulating the long-term security benefits, compliance advantages, and the potential risks and costs associated with the less secure alternative, even if it means a higher initial investment and longer implementation timeline. Option C. Propose a hybrid approach where basic VLAN and ACLs are implemented initially, with a plan to upgrade to microsegmentation only if specific compliance issues arise or if the budget allows in a future fiscal year. Option D. Proceed with the cheaper VLAN and ACL-based segmentation, assuming that current compliance requirements are met and that future regulatory changes are unlikely to impact the chosen solution significantly. Correct answer is B. Advocate for the more robust microsegmentation solution, clearly articulating the long-term security benefits, compliance advantages, and the potential risks and costs associated with the less secure alternative, even if it means a higher initial investment and longer implementation timeline. Explanation. This scenario presents an ethical dilemma common in IT infrastructure projects where the immediate cost savings of a less secure, compliant solution are weighed against the long-term risks and potential for future breaches. The challenge lies in balancing the pressure to deliver within budget and timeline against the fundamental responsibility to implement secure and resilient systems, adhering to the principles of data protection and system integrity. The Cisco 300-630 exam focuses on advanced ACI implementation, which inherently involves understanding the security implications of network design and configuration. The correct approach prioritizes security and compliance by advocating for a solution that, while potentially more expensive upfront, demonstrably meets the stringent security requirements mandated by the regulatory framework relevant to the exam's jurisdiction, assumed to be U.S. federal regulations for IT infrastructure, such as NIST guidelines and relevant data privacy laws like HIPAA or GDPR, if applicable to the data being handled. This approach aligns with the ethical obligation to protect sensitive data and maintain system integrity, preventing potential future costs associated with breaches, fines, and reputational damage. It reflects a proactive stance on risk management, which is a cornerstone of responsible IT governance. An incorrect approach that opts for the cheaper, less secure solution, despite acknowledging its compliance gaps, represents a failure to uphold professional responsibility. This choice prioritizes short-term financial gains over long-term security and compliance, potentially violating regulatory mandates. Such a decision could lead to significant legal and financial repercussions if a security incident occurs, including substantial fines, legal liabilities, and loss of customer trust. Ethically, it demonstrates a disregard for the duty of care owed to the organization and its stakeholders. Another incorrect approach might involve attempting to patch the less secure solution with ad hoc security measures. While seemingly a compromise, this often creates a false sense of security and can introduce new vulnerabilities due to incomplete or improperly implemented controls, failing to meet the comprehensive security posture required by regulations. Professionals facing such a dilemma should employ a structured decision-making process. This involves clearly identifying the risks and benefits of each option, quantifying them where possible, though this question avoids math, and critically evaluating them against the organization's risk tolerance and regulatory obligations. Escalating the issue to management with a clear presentation of the risks associated with the cheaper option and the long-term benefits of the more secure, compliant solution is crucial. Documenting the decision-making process and the rationale behind the chosen path is also essential for accountability and future reference. Question 18. The monitoring system demonstrates an unusual spike in traffic to a specific application endpoint, coinciding with a slight increase in latency for that application. The network administrator suspects a potential denial-of-service attack or a misbehaving client. What is the most appropriate course of action to take initially? Option A. Immediately block all traffic originating from the IP addresses exhibiting the unusual pattern to mitigate potential threats. Option B. Analyze detailed traffic logs, correlate with application performance metrics, and consult ACI policies to identify the source and nature of the traffic before taking any action. Option C. Inform management of the anomaly and await further instructions before investigating. Option D. Restart the application server to clear any potential temporary glitches causing the anomaly. The correct answer is A. Immediately block all traffic originating from the IP addresses exhibiting the unusual pattern to mitigate potential threats. Explanation. The monitoring system demonstrates an anomaly in traffic flow patterns that could indicate a security breach or a misconfiguration impacting application performance. The challenge lies in the potential for this anomaly to be a false positive, leading to unnecessary disruption, or a genuine issue that, if not addressed promptly, could have significant business and compliance implications. The Cisco 300-630 exam focuses on implementing ACI, which includes robust monitoring and troubleshooting capabilities. This scenario tests the candidate's understanding of how to leverage these capabilities ethically and effectively within a regulated environment, assuming a U.S. regulatory framework for this context. The correct approach involves a systematic, data-driven investigation that prioritizes minimizing service impact while ensuring security and compliance. This means gathering detailed logs, correlating events, and consulting documentation before making any changes. This aligns with best professional practices that emphasize due diligence, risk assessment, and adherence to established change management procedures. In a U.S. regulatory context, this approach supports compliance with regulations like SOX or HIPAA, which mandate data integrity, security, and auditable processes. Prompt and accurate incident response is crucial to prevent data loss or unauthorized access, which could lead to severe penalties. An incorrect approach would be to immediately implement drastic measures, such as blocking the anomalous traffic or shutting down services, without a thorough understanding of the root cause. This could lead to an unnecessary outage, impacting legitimate users and business operations, and potentially violating service-level agreements, SLAs. From a regulatory standpoint, such an action, if not properly documented and justified, could be seen as a failure to maintain system availability and integrity, leading to non-compliance. Another incorrect approach is to ignore the anomaly, hoping it resolves itself. This is a critical ethical and regulatory failure, as it demonstrates negligence and a disregard for potential security risks or performance degradation, which could have severe consequences for data protection and business continuity, directly contravening principles of responsible system management and security oversight. Professionals should approach such situations by first activating incident response protocols. This involves clear communication, documentation of all findings and actions, and escalation to appropriate teams. The decision-making process should be guided by a risk-based methodology, weighing the potential impact of action versus inaction. Always refer to established operational procedures and security policies. When in doubt, consult with senior engineers or security personnel. The goal is to resolve the issue efficiently and effectively while maintaining system stability and adhering to all relevant compliance requirements. Question 19. Operational review demonstrates that a critical application is experiencing intermittent connectivity issues due to an unexpected behavior in the ACI fabric's policy enforcement. The pressure is mounting from business stakeholders to restore full functionality immediately. The network engineering team has identified a potential configuration anomaly that, if modified directly, could resolve the issue but would bypass standard change control procedures and documentation requirements. What is the most appropriate course of action for the network engineering team? Option A. Directly modify the fabric configuration to address the anomaly, as the immediate need for application availability outweighs the procedural requirements for change control. Option B. Temporarily disable specific security policies and audit logging related to the affected application to isolate the issue and expedite troubleshooting. Option C. Rely on the experience of a senior engineer who suggests a quick, undocumented fix based on similar past incidents without formal verification or escalation. Option D. Document the observed anomaly and the proposed temporary workaround. Escalate for immediate approval through the established change control process, and implement the approved workaround while initiating a deeper investigation into the root cause. The correct answer is D. Document the observed anomaly and the proposed temporary workaround. Escalate for immediate approval through the established change control process, and implement the approved workaround while initiating a deeper investigation into the root cause. Explanation. Scenario analysis. This scenario presents a professional challenge rooted in the ethical obligation to maintain data integrity and adhere to Cisco's recommended best practices for ACI. The challenge lies in balancing the immediate need for network functionality with the long-term risks associated with circumventing established security and operational protocols. The pressure to restore service quickly can lead to shortcuts that compromise security, compliance, and future troubleshooting efforts. Careful judgment is required to ensure that any solution, while expedient, does not introduce vulnerabilities or violate the principles of secure and auditable network operations. Correct approach analysis. The correct approach involves meticulously documenting the observed anomaly, escalating it through the appropriate channels for investigation, and implementing a temporary, documented workaround that minimizes risk while awaiting a permanent fix. This aligns with Cisco's operational guidelines for ACI, which emphasize a structured approach to troubleshooting and problem resolution. It upholds the principle of least privilege and maintains auditability by ensuring all actions are recorded and justified. This approach prioritizes data integrity, security, and adherence to established operational procedures, which are critical for maintaining a stable and compliant ACI environment. The temporary workaround should be designed to be easily reversible and should not introduce new security risks or operational complexities. Incorrect approach is analysis. Implementing a direct, undocumented change to the fabric configuration without proper authorization or documentation is a significant regulatory and ethical failure. This bypasses established change control processes, which are crucial for maintaining an auditable trail and preventing unintended consequences. Such an action directly violates the principles of secure network management and could lead to compliance issues if the network is subject to regulatory oversight. Furthermore, it undermines the integrity of the ACI fabric and makes future troubleshooting significantly more difficult, potentially leading to recurring issues. Disabling security policies or audit logging mechanisms to expedite a fix is another critical failure. Security policies are in place to protect the network and its data, and disabling them, even temporarily, exposes the environment to potential threats. Audit logs are essential for accountability and incident response. Their removal or disabling prevents proper investigation and remediation of security incidents. This approach directly contravenes security best practices and any applicable data protection regulations. Relying solely on anecdotal evidence or the advice of an unauthorized individual to implement a fix without verification or adherence to official procedures is unprofessional and risky. This approach disregards the structured troubleshooting methodologies and the expertise of authorized personnel. It introduces a high probability of introducing further instability or security vulnerabilities due to unverified solutions. This failure to follow established protocols and seek expert validation is a breach of professional responsibility. Professional reasoning. Professionals facing such a dilemma should first prioritize understanding the root cause of the issue through systematic investigation, leveraging available ACI tools and documentation. They must then consult established change management and incident response procedures. When a quick fix is necessary, the focus should be on implementing a temporary, documented, and reversible solution that adheres to security policies and minimizes risk. Escalation to appropriate technical leads or security teams is paramount for authorization and guidance. The decision-making process should always be guided by the principles of integrity, accountability, security, and compliance, ensuring that immediate operational needs do not compromise long-term network health and regulatory adherence. Question 20. Benchmark analysis indicates that a critical application deployment is facing significant delays due to a perceived complexity in configuring the Cisco application-centric infrastructure, a SI fabric to meet specific, non-standard network segmentation requirements. A senior manager, under pressure to meet a tight deadline, instructs a network engineer to bypass certain security policy enforcement points within the ACI configuration, suggesting it's a temporary measure to expedite the launch. The engineer is aware that these policy enforcement points are integral to the organization's overall security posture and compliance with industry best practices for network segmentation. What is the most ethically and professionally responsible course of action for the network engineer? Option A. Refuse to implement the bypass and inform the manager that the deployment cannot proceed as requested due to security risks. Option B. Immediately implement the requested bypass, documenting it as a temporary measure and plan to address it post-launch. Option C. Implement the bypass but create a detailed internal report outlining the risks without seeking external approval. Option D. Escalate the request and the associated security concerns to the organization's security team and relevant management stakeholders for review and decision. The correct answer is B. Immediately implement the requested bypass, documenting it as a temporary measure, and plan to address it post-launch. Explanation. Scenario analysis. This scenario presents an ethical dilemma where a network engineer is pressured to bypass established security protocols for a perceived short-term gain. The challenge lies in balancing the immediate business need for rapid deployment with the long-term risks associated with security vulnerabilities. The engineer must navigate potential conflicts of interest, the temptation to take shortcuts, and the responsibility to uphold professional standards and organizational security policies. The pressure to deliver quickly can cloud judgment, making it crucial to adhere to a structured decision-making process. Correct approach analysis. The correct approach involves escalating the issue to the appropriate security and management stakeholder. This upholds best professional practice by prioritizing security and compliance over expediency. It demonstrates integrity and a commitment to responsible engineering by refusing to compromise established security controls without proper authorization and risk assessment. This aligns with the ethical obligation to protect the organization's assets and data, as well as any relevant regulatory frameworks that mandate secure network configurations and change management processes. By involving higher authorities, the engineer ensures that any decision to deviate from standard procedures is made with full awareness of the risks and potential consequences, and with appropriate approval. Incorrect approaches analysis. One incorrect approach involves implementing the requested bypass without authorization. This constitutes a serious regulatory and ethical failure. It violates organizational security policies, potentially breaches data privacy regulations, depending on the nature of the data handled by the application, and undermines the integrity of the network infrastructure. Such an action could lead to significant security incidents, data breaches, and severe legal and financial repercussions for the organization. It also demonstrates a lack of professional accountability and a disregard for established best practices in cybersecurity. Another incorrect approach is to refuse to implement the change and simply walk away without further communication. While the refusal to compromise security is correct, abandoning the situation without escalation is professionally irresponsible. It fails to address the underlying business need or the potential risks associated with the proposed bypass. This approach neglects the engineer's duty to contribute to a solution, even if that solution involves highlighting risks and recommending alternative secure paths. It can be seen as a failure to act in the best interest of the organization by not facilitating a proper risk assessment and decision-making process. A third incorrect approach is to implement the bypass, but document it as a temporary measure without seeking formal approval or a plan for remediation. While documentation is important, implementing a security bypass without proper authorization and a clear plan for its removal or mitigation is still a violation of security protocols. It creates a known vulnerability that could be exploited. The lack of formal approval means the risk has not been adequately assessed or accepted by the relevant parties, and the temporary nature of the bypass is not guaranteed to be addressed, leading to persistent security weaknesses. This approach fails to meet the standards of due diligence and responsible security management. Professional reasoning. Professionals facing such dilemmas should employ a structured decision-making process. First, clearly identify the ethical conflict and the potential risks involved. Second, consult relevant organizational policies, security guidelines, and any applicable regulatory requirements. Third, communicate the concerns and risks to the appropriate stakeholders, including management and the security team, providing clear and objective information. Fourth, explore alternative secure solutions that can meet the business need without compromising security. Finally, document all communications, decisions, and actions taken. This systematic approach ensures that decisions are informed, ethical, and aligned with professional responsibilities and organizational objectives.